Okay, today we're going to work through some practice problems. First, dealing with entity relationship diagrams. Now in your assignments, ERD review activity for credit. Basically what I've given you is a draw.o document to make a copy of and then to edit as we go through this. And all you need to do is share with me the link to your completed draw.io document. So let's open this document and then we'll get ready to submit it as a link. Now if you're logged into your MAS email account, I think it works better that way. So you click on that, it will want to open draw.io. Now last time we did this, it brought up just what looks like just an image. You're going to want to open it with draw.io. There we go. Up at the top should show open with, and click open with draw.io. Now if you're logged in and you've already used draw.io, it should not go through the authorizing your account. I had to go through that the first time. And then it will, oh, it looks like it's doing that for me. And allow that. Authorize. Oh, I guess I have to allow pop-ups. Didn't know this. I'm on a different machine. Let's see. Allow pop-ups for that guy. There we go. And now it's going to go through the authorization part. We will use my jsmart24, which I should already be logged into. And agree. And now it will then let you access that draw.io diagram if the internet is working fine and you're logged into the correct account. And here we come. It should be coming up any second now. We'll be editing some ERDs. Remember what ERDs are? They are showing you the relationship between tables. And I'm going to pause here. Okay, so up pops the draw.io document, which we now want to edit. First thing we want to do is make a copy of that, because you can only view this one I gave you. So let's go ahead and make a copy. I'm going to keep it in my Google Drive. And I'm going to rename it to put my name, username in front of that. I'm going to go jsmart. And rename it. And I can now edit it once it is mine. Okay, double click now, and I can change that to be John Smart. So you put your name there. Alright, here we have an example correction to an ERD. I can zoom in and out on this. We had initially been given this many-to-many relationship. And that's not what we want. So we want to fix that, replace it with the correct thing. And just to make it clear that I'm replacing that, I'm going to make it a dashed line, and I'm also going to change its color to red. Pick a red. These have been done for you. We had a relationship, a student can attend many courses. A course can be attended by many students. We can't use only two tables to resolve this relationship. We need what we call the associative entity, associating a course with a student, because many students can register for many courses. So we need a separate enrollment table. Now the name I give it, enrollment, could have been courses to students association, but enrollment is more meaningful. Or we could call it an attendance table. Often you get a clue from the verbs in the relationship. Because, or I could have said a student enrolls in many courses. A course is enrolled in by many students. Or attended might imply, well, let's call that an attendance. But you know what attendance implies. That implies a daily attendance, not a contract to enroll. So enrollment's a better name. The primary key is going to be a combination of the two keys that it's creating the association with. I could make a separate primary key, but why do that if this is sufficient and this is a common way to handle association, the associative entity? make it the primary key the combination of the two things we're associating. The information that goes in that enrollment table is only information specific to a particular student in that particular course, such as the date that particular student enrolled in a particular course, and the grade that they received for that course. As you think of college rules, you might think, well, what if the student failed the course and wants to take it again? Well, then we'd have to treat this differently and perhaps have a semester ID or a semester number go along with the course and make that part of their primary key, because we know in this case, because the primary keys have to be unique, that a same student cannot enroll in the same course ID multiple times. That's just the rules about primary keys. They must be unique. So we won't worry about that extra thought. We'll just say, okay, we're resolving this simplistic course to student many-to-many relationship. And this is the answer to that. Now, down below, you're given another relationship that we're going to resolve a many-to-many relationship with. And since it's the same sort of solution, let's go ahead and make a copy, Control-click on each of those. Make a copy, Control-C, Control-V, and now drag it down. This is going to be a relationship we'll establish here. And let's go ahead and draw the lines to the primary keys. The lines there, I can just click off it and now select that one line. Now let's just select the one line, there we go, and then grab the end and connect it, and it should behave properly once I'm connected in the right way. There we go. Click this one, grab the end, click, drag, come back to that, and when I'm connected, there we go, it will go green. Now, the names, instead of student ID here, this one is going to be book ID. I haven't even thought about what exactly the table name is, but I know it's going to resolve this, so let's go ahead and connect it to the two primary keys of the tables that need to resolve that many-to-many. And let's think about the relationship. Let's see, a book, always this singular, a book, or each book, or one book. A book is written by, well, you might think, one author. Will that resolve the relationship? Well, that will be a change in the implied rule of many-to-many. This is implying that many authors can work on one book, and a book may have, or a book may have many authors. So keeping that rule in mind, we don't just change the crowfoot to one over here and think we're done. No, we need to keep the many-to-many. A book is written by one or many, or could be written, I'll say one or more authors. And going from right to left, one author can write or be involved in the writing of many books. That's the relationship. So now what should our table be? Implied by the verbs here, written by, can write, we could call this the composition, the book to author table. Let's just use that. Let's call it book and book to author. And you can put numbers in table names as long as it's not the first item in the, or first character in the name of the table. Book to author. That relates a author to a book. Now, what is specific to that book? Well, we have date enrolled for students. How about date contracted or date began? I'm going to put the date of the contract. It's essentially a contract. And now, what's associated with that book's and that particular author? Thinking especially of managing multiple authors on a book. Well, let's call it the percent or the fraction or the amount of contribution. I'll call it percent contribution or percent royalties. The name you give it is kind of your choice. but it's specific to that particular author and that particular book. Don't put email, because that's an author's information. There may be times when you may have a similar field, but remember, whatever field goes here is specific to that book to author relationship, that specific book to a specific author. If he's working it together, well, percent contribution. If it's 100%, then it's 100%. Okay, so just to indicate that that's no longer the relationship, let's make that dashed and give it a red color. And notice on these lines, to make it more readable, I increase the width of the line to 2, and I increase the size of the end to 13 point. By default, it's so tiny, it's not very easy to read. Alright, let's make a copy of that table now. I can do Control Select, Control Copy Paste, and drag down to the next problem. And here I'm going to, again, connect them up. Click that line, grab that connector, click this line, grab and connect to the employee ID, and translate the new name. Employee ID is the association on one side, the author ID or project ID is the association on the other side. Now, how would we describe this relationship? Well, one employee works on many projects, or is involved with, or is assigned. A employee is assigned to multiple projects, many projects. One or many, you could decide if it's 0 or many. And a project has many members, many employees working on it. Is worked on by many employees. So, is worked on by many employees, is assigned to many projects. So how about we choose assignments? And I like to use singular on my table names just as to be consistent. It could be workload or work signed up, project to employee, if you want to use that kind of title. Now, what kind of information is specific to an employee and a project? Well, the date they signed up for the project, or the date assigned. How about instead of date contract, let's call it date assigned or date joined. I like to imply the type of data in the name. That's something more of a convention. The percent contribution, how about their percent of their time, percent time, or commitment. Sometimes you commit to 50% of your time you're spending on that project. Depending again on other business rules, how you determine their pay. Percent time times how many hours in the project. I suppose you could even keep track of the hours, but that sounds like a separate table because you're making multiple hourly reports. So, but that report may use this primary key of the assignment table, tracking the hours for a specific employee. Oh, and let's just indicate that that one's what we're replacing, dashed lines and red color. Now you can see it's, as we get a little practice here, let's see if I can select through that. It looks like if I'm just touching the objects, they will get selected. Oh, maybe not. Control select, and copy paste, and start the next one. Make our connections. Click off, click the line. Oh, look, it lost my border. I guess I don't want to do it that way. Let's click, and then control click, copy paste, and drag down. It is a little bit of an awkward program and sometimes it doesn't behave like I expect. And make our connection, click off, select that, connect to there, click, drag the end, connect to there, and now make this the movie, and the actor ID. And let's think about the verbs. A movie may have many actors. So double click. A movie, the one side, movie, has many actors. One to many actors. It could be zero to many actors, right? Actors. An actor can act in many movies. Well, what should we call the table? Assignment. You're cast in a movie. You are acting in a movie. Actor to movie table. Let's choose that. Let's try actor to movie. Just to show you that there is a variety in how you name this. I would name it something that's most obvious to people that are coding it, what this table is about. Casting, that's probably a decent term as well. And I'll say date contracted or date, yeah, I'll say the date of the contract. Date signed on, the date they signed for the movie. And percent time, something specific to that actor. How about pay per hour? Some may be paid on one time. We're saying they're getting paid per hour. And that will be in a separate table. But we know from this that for that particular movie, for that particular actor, this is the date they signed the contract, this is the agreed upon pay per hour for that specific contract. And click that, and dash line, and red. Replacing the many-to-many, which is impossible to do in our database, with the one-to-many on both sides. And continue. Hopefully you're seeing that this is pretty straightforward. As you practice, it's like, oh yeah, that's the connecting is easy. It's the figuring out what's going and what that table is about, and what fields go in there. All right. Customers to products. So we're thinking the many-to-many relationship is a customer, or each. Let's do each customer. Each customer purchases many products. A product is purchased by many customers. Well, since we use the verb purchase each time, why not use that as our table name? Call it purchase log, or purchase log. Or the purchase table. Oh, shorter word. Matching the primary key from that table, customer ID, in combination with the product ID, makes a valid primary key for this table. Combination keys are common. Combination keys are common in associative entities. And let's see. How about instead of date signed, date purchased? Date purchased. Now this comes into here an idea that what price did they pay for the product at the date of purchase? That seems to be pertinent to a specific purchase. We could say quantity here as well, and say, well, whatever price in the product, it multiplied by quantity was how much they pay. I'm going to just do something here, just to think of business rules, and a reason why sometimes you may have the same item in two tables. The reason is the price on the date purchase may be different than the price tomorrow that would be updated here in the product table. For historical reasons, I am going to keep track of the price, and I may also keep track of the quantity as well. And I think I can add fields. Let's see, I can select that, and I can do edit duplicate, and now I can make that be quantity. Anything that's specific to a specific customer and a specific product would go into the purchase associative entity. Alright, one more here. Let's select that one, Control, select, Control C, Control V, drag down some more. And let's connect our lines. Click off, just select the line, connect, select the line, connect, and put in the driver ID here. Notice I like to do consistently left to right. The one on the left goes first, the one on the right goes second. And now the relationship. I think you're finding this easier as we go. A driver can drive, may drive many vehicles. Not at one time, of course. A vehicle is driven by many drivers, not at the same time. So, instead of date purchased, we could say date driven. Instead of price, it could be odometer at the start. And since we have space for another one, since I added one before, let's make that odometer end. And there could be plenty of other information there, like condition, where was it taken, all sorts of, oil level at that time, at that point in time. And instead of purchase, this would be, what would you put there? It's drive, it's driven by, you could call it the vehicle log, or drive log, or driver to vehicle log, or drives. They drive it. A drive is, but that's driver and drive. That's not a good name. How about we call it the trip table? They take a trip. And oh, I forgot to do it in the last few. Select, Control Select, and Control Select. And make both of those dashed and red. So part of this, you're just learning to interact with the draw.io. The reason it's a kind of an awkward drawing program, but what wonderful thing it has in there, I can have entity relationship lines that I don't have to compose myself. They're all in there. I can use those. Now, because they were already in there, copying and pasting an existing one with the nice correct scaling is a little easier to use. But I can always draw my own if I have other relationships. I added those lines using the add more shapes, the plus more shapes. And that's the last of our entity relationship diagrams. Now we'll go on to the next practice. Oh, and all you need to do with this now to make it, to submit the assignment, is either on the file share or this button share up here. And you decide to share it with anyone on the internet, but they only have viewing capability. That just makes it less of a hassle. When you give me a link, I can view your wonderful completed work. Now normally you would be wanting to export, so I have an exact copy of what you had. Oh, and now here's how I have to share it. I can't share it that way. I have to click open the Google Drive where it's located, and then I choose this one that I just drew. I didn't realize I gave it the same name as the other, another previous one. I can then just click here, and here I can then do the share. And in the sharing, I click here, share, and I want to not restrict it to a particular people. I want to say anyone with a link. Notice anyone with a link is only a viewer. I could make them a commenter. Go ahead and make me a commenter, or anyone that you give the link to can be a commenter. And I will then copy the link, and I'm done sharing. Now I can go back to the assignment here, and in the submission, I click submit, and I, in the create tab, copy the link, or paste the link, and now select that text, and click link here, and paste it there. Oh, and let's go back and edit that. I like to make it open a new tab. Now, another way to do that could be click the link first, paste your URL there, check, and there, and now I have an active link as well. And now I submit it, and I will now see your shared document. It's kind of a little experiment I'm doing, just see how easy is that. It's not frozen in time, so this would allow someone to make corrections before you finally got it graded. But it's convenient and kind of experimenting with the sharing part. And that's that for that assignment, just practicing the ERD. Now let's go to the little more challenging assignment, where it is practicing some SQL coding. We're not going to be able to get through all of them. I may give you some more practice through this next week. And the reason for this, I want to have this to give you plenty of practice, and Sam's asking what to do. I'm saying flexible as I know everyone is getting it. We should have this done at least by next week. At least by 11/7. I'll say at most by 11/7, not at least by 11/7. Okay, so let's take a look at that SQL practice. Here's the document I've shared with you. Going to do the same thing. Let's click that document. This time you're going to save it as a Word document and upload it here. So let's click that shared document. And first of all, make a copy of it. Make a copy. Because you can't edit this one. Let's go ahead and name it JSmart. cs312, and make a copy in my drive. If you had subfolders, you could edit that. And let's go right ahead and put your name here. Oh, and there's the new name, John Smart. And just to make it easy for your instructor, you could give the text, all the text that you do, a special color. Now, I've given you an example one just to show you the kind of solution we're looking for. And we can use SSMS to actually validate or verify my queries. Now, you may get AI to help you with this as well, but make sure you understand what you're getting. Don't use AI at first. If you get stuck, you can have it help you. No guarantee if they've given you the right answer. If you use AI, you better make sure it gives you the right answer. But try to do it yourself, because you have an example here to work from. So you're being asked to create a table for books, authors, and they're giving you the name of the associative entity. So you don't have to worry about the name. They tell you the name. And even some fields to put in that associative entity, like contribution percentage or percent, payment. And you're going to write a query that creates the table and then inserts the books and retrieves books by specific authors, and also lists all the authors who contribute to a particular book. What do I mean by that? Well, let's take a look at the example solution here. This is the schema for 3 tables and the linking of them. First of all, here's our first table. It's fairly simple, and don't worry about making it too complex. Have something at least with a key and then some information about. And they may give you, in the question, they may give you fields that should be in there. In this one, notice it doesn't say, it just says you need an authors table. And in the question, it does say, well, we need to know listing of authors. Well, that implies the name of an author. So what goes here is your choice. I would always make my table ID similar to my table name. I would have actually chosen singular author instead of plural author, just because I like the name of my table singular. I think in my mind the logic fits better. Author name when I'm referring to a single author in the table. Good. That would be the fields to create in those 2 tables. So there's some flexibility in your solution. The actual name. Actually, no. It did say the name of the table right here. So yeah, use the name given. If I had not been given that, I might have used singular names. So there's how to create the author's book. I have an author ID. Just make it a practice. Make your IDs integers in all your tables. And make the ID the primary key. As you work with combination key, which will be in the associative table, you'll see how that's created. So there's a primary key in that table, and then this table, books, has a primary key, book ID, and something about the book. Yeah, book title makes sense. And since it's text, we'll make it varchar. Fairly simple structure to that table, books table. Now the book authors table, this is where we're connecting using the foreign key syntax down here. But the first part about the data going into it is this. I have a book ID. Since I'm making a combination primary key, I don't put primary key here. I just say it's an integer. The author is an integer. Here's the data specific to a particular author, the contribution to that book, and how many decimals and digits after the decimal, how many digits before and after the decimal. And now I say my primary key is the combination of those first two primary keys in those other tables. How do I know about what those are? These tell me, oh, by the way, book ID is referenced to the book ID in the books table. Author ID references the author ID in the authors table. This is telling SQL how that connection is made. And remember in Access when you edited your relationships, that's essentially those connections between your tables. That they are connected one to many. This is the one side, this is the many side. You don't see that here though, do you? It's hard to figure that out, but thinking through that and knowing about this, you know, oh, that's the one side, author ID. And the many side must be the combination, or the many side in the book. Many books can be written by the author. In the books table, the book ID can be written by many authors. Combination key, and now questions about how to insert data into that. We haven't done a lot of that, so it's great to go over that with practice. Remember the syntax. Insert into what table I'm adding data to. So insert into table name. The columns that are going to be changed or given values are listed in parentheses, separated by commas. So the book ID is going to be assigned the value 1. Book title will be assigned value, the second item in this list. String around it, that's the second item. So what columns I'm going to be putting values in, and then the values keyword, and then in parentheses, one or more pairs of or sets that match the same number of items as listed here can be then entered there. And if I want to put two entries, here's the syntax, values and their values in pairs or in sets, the same number of items as is there, author and author name. We'll get the values 1 and Alice here, and the next row will get 2 and Bob. And it will give me an error if I ever try to enter another 2 into the authors table. It will say, wait a minute, there's a duplicate entry. You can't have more than one same author ID. Here is entering data into the associative table. 3 columns, I specify them in the insert into table name. 3 column, book ID, author ID, that's the primary key. The contribution percentage of 50% for both authors. Same book, book ID number 1, book number 1, author 1 and author 2. And they're both sharing the authorship by 50%. So that is entering. Remember CRUD, create, read, update, delete. An insert is like an update. Now the next one, retrieve all the books by specific author. We're going to do the inner join format, and I'm going to show you my preferred format when I'm writing code. I think it's easier to read, but let's read through this first. And we see a new format, basically making it a way for our queries to be a little cleaner looking, right? So I can have long column titles, wrong field titles. But in a query, that gets kind of cumbersome. So here's a way to say, when I'm selecting a particular column from a book that I'm designating as just the letter B, this here says what B means. I'm saying select from the book, from the table name books, but we'll alias it, or another name for it is what comes next. So books, space, an alias for that book. Join on, this time I have the book authors table. I'm going to be referring to it as book A from now on. And the join is on the condition that every item with the book ID in the book table is only selected if it matches the same item in the book author's book ID table. So that's the referential integrity, or that's the joining property, the joining of those two columns in those two tables. I only get the data where these two things are equal. And also, I'm looking only for the data where the author's ID is 1. I'm going to show you what I think is easier to read version of that query and equivalent to it. Here's how I like to write it when I'm writing code. Same book, I'm selecting information from the table I'm referring to as B. And this tells me, oh, B is referring to is aliased. The letter B is alias of the books table. And instead of join, I'm going to do this. I like to do this in comma. I'm also getting information from that table. And instead of on, I do where. And all conditions following that are followed by an and. This is the equivalent query as that. You can decide which is easier to read in your code. I think this is easier to read and understand. I'm saying, give me the information, just the book title, from these two tables, aliased as B and BA, with this condition. Only give me the data where the book ID matches in both tables. And since I'm looking for a specific book or a specific book by author number 1, I'm looking for this additional part of the where clause. So the queries get longer as they get more complex. The where clause gets more complex. This is the listing of what columns I'm going to be, or what tables I'm getting the information from. This lists what columns I'm going to be displaying or selecting for further processing or for display. So that's the format that I like. And now listing the authors. Let's take a look at this. All the authors that contributed to a particular book. Well, in this case, I'm looking for a specific author for that particular book, and I'll just refer to it as ID number 1. If I want to associate it with a title of a book, then I would say where B.bookID or book name has a certain name. Well, that would be more complex query. So let's go with a simple query. I just know the book ID's number is 1. Well, to see just the list, just the author's name. Notice I'm only asking to list the authors. I just say, give me the author's name of the table aliased as A. Well, that would be the authors table based on this line. Yeah, authors, whenever I see an A, that means it's referring to the authors table. Joining the information, meaning only getting information where the two columns in both tables, the author ID equals author ID in the book authors table. So this is telling me anytime I see BA dot something, that means the book authors table. A dot something, this is saying A is referring to the authors table. Now, it's up to the writer of the code to make that letter something meaningful. Like BA, I could have just used the letter B there, but BA reminding, oh, we're talking about the book authors table whenever I see the BA, as the query gets long and complex. Now, to really test this, I would run this query on SQL Server Management Studio, paste it in a new query after creating a database just for this homework to test all my queries. And you can run all these queries, and I have successfully done it, and it shows that, yes, that is the correct query. I'll do one more and then let you work on the rest. Okay. can look at the reference here. How do I create a table? Remember, it's just the name of the syntax. Let's go ahead and copy that. And let's just get started with that. Since I know that's the general syntax for creating a table, let's do an insert of a table cell. And let's just put creating tables. Creating. Well, what's the name of my table? There's students and courses. Well, it's going to be student ID, not author ID. And instead of author name, let's say student name. Let's see if in the question itself does it indicate other fields. All students enrolled. That implies student name. Number of courses each student is enrolled in. Oh, I'm going to need to write a counting query. Courses in a particular student is taking along with their enrollment dates. Oh, I need to see the enrollment dates. To me, that implies that enrollment date, oh, look at that, enrollment date is in my enrollments table. There, I'm given the names of my tables. So let's go ahead and create the students course, or the students table. There we have it. Let's copy that, just because I know it's going to be a similar syntax for the next one. This is going to be not students, but courses. Courses. Course ID here. And student name, that would be course name, right? Let's check to see. They don't say what goes in my courses table, but I think course name would be a good thing to put in there, along with course ID. Now, just like we have our associative table, let's make a copy of that, just so I know the syntax of creating an associative table. And we'll just rename our fields to go with the new table. So start with a known working syntax and have that. Retrieve all books by a specific author. Oh, that's, sorry. Here we go. All courses particular students take along with their enrollment dates. We're creating the enrollment date table. Here's my associative table. Well, they told me the name of my table. It's called enrollments. They did tell me that I should have an enrollment date in there. Let's go ahead and make that field in there as, well, let's see, let's just do this. And now the primary key is going to be the combination, not enrollment book ID, but student ID and course ID. And the foreign key into the table is going to be references the student's student ID. So let's get the foreign key. So combination of this. So the key is going to be first part of the combination key is the course student ID. References students parentheses student ID. Saying part of my primary key. Well, here is saying the primary key is composed of these two things: the student ID and the course ID. How do I get them? Well, student ID references the students table, the course ID there, references the course ID, the course ID in the courses table. So I've got the primary key part figured out. And let's see, they did say enrollment date. I could include other things in the enrollments table, but there's plenty there for now. So what I'm saying here is I have I have these two fields, an enrollment date as type date. These two fields are type integer. The primary key is a combination of these two fields. And these two fields are related to these other tables. It's related to the students table, the student ID field. This is related to the courses table with the course ID. Now, SQL itself doesn't demand that you name it the same, but it sure would make sense and be not less confusing to anyone reading your code, that you keep the primary key name the same across tables. That's why ID, although it works, how do you know what table you're getting the ID of? It's best to make it clear, yes, I know I'm using the student ID in the students table. And now we have one more, we have the creation of the table. That is part one. Now, list all the students enrolled in a specific course. Let's see if we can write this without we'll take a look at the example, but not copy paste. I select the student, and I need a join between that and the other table, either the associative or the other table. That's the one-to-many side. Depending on the query, I may choose another table. But with this particular one, I want what I want to list. It says all the students were enrolled in a specific course. Well, a student is enrolled in a course. Well, it does say, do I want to list the name of the student enrolled in a specific course? Let's do that. And let's go by specific course. We'll just refer to it by the course ID. It'll make our queries simpler. So I want to list the student name, and I might as well list the course ID just to verify that it is that when I see the listing, I'll know that's the course they're signed up for. So let's do a select. What do I want to get? I want to select the students, right? Let's say s dot student name, comma, let's do e dot course ID. From, right, the from clause, remember how that worked. From, and now I'm going to choose from students plural because they use the plural in the students, space, and then the shorthand or the alias short version of the table name. And here's where I do the join. And now the second table, the enrollments table, just like the other one. First table joined with the enrollments table, give it an alias, and then on what fields are matching. So down here, join enrollments, treat that as E on S dot student ID is equal to E dot student ID. Now we're not done. Right now this will give me all the student names and their course ID for all the courses in all the courses that are listed in the enrollments, that have enrollments on them. Well, I only want to list it for a specific course, right? It said in a specific course. Well, I'll just choose the course where E, the enrollments, dot course ID is equal to 1, course number 1. That is a particular course. Now, if I want a specific course that's by name, that's a different query. Let's go with the simple query. Show me the course whose ID is 1. That's a particular course. Alright, now I want to get count the number of courses the student is enrolled in. Well, how would I do that? Well, let's see here. I first want to figure out what would be the field that I'm counting. Let's see. How would I find out? Let's see. In the enrollments, no, the enrollments table knows all the enrollments for a particular student, right? Because enrollments has a student ID. So if I just did select star from enrollments where student ID equals 1, I'll get a listing. But I want to count, of courses, for each student. So this gets more complicated. We're going to have to do some grouping and some selection. So let's first start with the easy part. Let's just do a select. Let's call it s.studentName. And then we need the number of courses. Well, how am I going to get the number of courses? I need to count the contents of what comes back from a query result. So I want to do count. And I'm going to go quick look up the solution so I get this right. I want to count the number of elements that show up inside the parentheses. So I want to count something. I guess let's just leave that here. I'm going to do a count of something. We'll come back to that. We're going to get the data from where? Well, let's see here. I'm going to get it from, join. Well, better include the students table because I need student information. So I'm join students. And I'm referred to that as letter S. On, what is it? On what table name? Enrollments. To refer to that as E from now on. Where, well, s.studentID is equal to e.studentID. So what am I going to get from here? Without worrying about what goes in here yet, I'm going to get a student name from every row in enrollments where those rows where the student ID matches from the student table and the enrollments table. Now it doesn't say for a particular student, all right? It's taking along with their enrollment dates. Now at this point, I want to know how am I going to count? What's going to go in here? Well, how about I just count how many student IDs I get out of that that query. So what I want to put here in the count is the count of something. Let's see, the count, what am I going to get here? When I have students joined with enrollments, well, what information do I get? Well, what do I get from students? I get the student ID and the student name. Here I get, in enrollments, I have the enrollment date for a particular course. Well, if I just count how many elements I have in the listing of courses where the student ID matches a student, I can just say count of the enrollment table, the course ID. Now there's one thing that we have to do here to count it by specific course. I have to add this at the end, group by, and we'll sort it on student ID. So I'm going to be counting the same student ID. It's going to be grouping the data and then giving me the count of that. Now something that they add in the solution, I'm not sure you actually need this, I will test this on SSMS, is they put this as course count. I'm going to try it with or without course count, because I don't think I need the as course count. I think this just, we'll see, I think this just means that's become the title of that column. Now the other ones, let's see, the other ones are simpler. Inserting data. Oh, I did show you the insert part. Let me show you the insert. Oh, I guess here, it didn't say write queries to do the inserting of students. Do they give you that in the... Yeah, I guess it doesn't ask for the insertion. In the next one, they actually to insert data into the table. So we'll stop that there. We'll test this. I'm going to test this in SSMS and see, do I really need this part in the course count? This is one. Go to your textbook and analyze what that means. I'm going to make that dark red to indicate that's my answer here, and I think I'll color these red just because that's my answer. Alright, we'll stop there. I gotta run.